lesson 25. You guys ready for lesson 25?
Yes.
Okay, here we go. So, we are going to be adding and subtracting some rational expressions, okay? We're going to treat them just like we would normal fractions. So that's why we're starting with these normal fractions, right? The idea with this one is to show you that we would actually write this as, 3 plus 6 over 10, since our common denominator is 10, right? So we're going to be using this very simple idea throughout the lesson. And that, of course, is going to become 9 tenths. So let's apply that idea to something even simpler right over here, such as number 2. What's our common denominator for number 2? So now we have to find one. It's the smallest number that's divisible by both 20 and 15. So not the smallest number that divides them, but the smallest number that's divisible by them, which is 60. And in order to get 20 to be 60, I have to multiply that by 3, right? So I wind up with 3 over 3 times 3 over 20. And in order to get the 15 here in this denominator to be 60, I need to multiply it by 4. So I'm going to multiply it by 4 over 4 times 4/15. So we'll go ahead and multiply now. So we'll multiply both our numerators and our denominators. That will give us 9/60 minus 16/60, which becomes -7/60. I just wanted to point out some weird stuff with a negative sign like that, because I've seen some weird stuff go on. Isn't it true that this is the same as this, which is exactly the same as this, which is the same as that, right? Those things are all the same. They're just different ways that I can manipulate a rational expression that has a negative sign. Okay? So we can do a lot of different stuff with that. Just want to point that out. Because a lot of the times that's where people make mistakes on these, is with their signs. So lots of sign errors happen with these. So our common denominator for this one is 20. So in order to get that, what I have to do is I have to multiply pi over 4 by 5 over 5. And this one I'll have to multiply times 4 over 4, right? So that we can get that common denominator. That's over 5. Okay. So that gives me 5 pi over 20 plus 4√2 over 20, which, just like we did in number 1, is going to wind up, we can rewrite that as 5 pi plus 4√2 all over 20. And that's the concept. All right, let's do this next one. Our common denominator here is going to be 2m, right? Because 2m is the smallest quantity that is divisible by both m and 2m. So when I multiply that, so in order to get a 2m here, I have to multiply by 2, right? So I have to go times 2, right? So that means that if I need to multiply the denominator by 2, we got to be fair and multiply the numerator by 2 as well. In this case, that second term, b over 2m, okay, so that one doesn't need to be multiplied by anything, and in order for this one to be c over m, I'm going to have to multiply it by 2, which means I need to multiply both my numerator and my denominator by 2. So this becomes 2a over 2m plus b over 2m minus 2c over 2m. I get to put those all together because now they have a common denominator, so this becomes 2a plus b minus 2c all over 2m. And did you see, for the reasons that I told you earlier, right, it's fair for me to go ahead and make this minus sign live in the numerator. Okay. So with this one, our common denominator is 20. So that means that I need to multiply. In order to get this 4 to be 20, I need to multiply by 5. So I'll multiply both my numerator and my denominator by 5. And I'll multiply both the numerator and the denominator in this one by 4 in order to get that denominator to be 20 as well. There we go. So normally I would go ahead and distribute this right away, but I'm going to go ahead and write out the in-between step and write this as 5 times a plus b over 20 plus 4 times 2a minus b, right? I'm just signifying that we have to distribute those across our numerator, okay? Don't forget about that second term. Sometimes it happens that I'll wind up getting a 5a plus b out of this. And that's no good, right? This right here should be 5a plus 5b. We're going to be distributing. And so let's go ahead and do that. I'm going to write this next step down over here. So that's going to be 5a plus 5b over 20 plus 8a minus 4b over 20. We're going to go ahead and put those together since now they have a common denominator. And again, I'm taking a bunch of extra steps that I normally wouldn't take, but it's the first time we're doing this, so I want you to see every little intricate step. It would be fairly simple to skip a bunch of stuff, right? To actually combine our like terms when we went from this step to this step. You might just go ahead and add the 5a and the 8a right then, and that would be fine. But let's do it right now. So 5a plus 8a is going to be 13a, and 5b minus 4b will leave me with just a b left, or 1b. You don't want to say a. And that's our final answer. It's been simplified. I can't factor anything out. All right. Next. Number B. Letter B. Here we go. What's the greatest common, common denominator, I should say? 15x squared. It takes a village. There we go. That's good. I like that. Which means that in order to get this to be 15x squared, I have to multiply it by 5x. So that means that I have to multiply both my numerator and my denominator by 5x. And this one doesn't need anything, right? It's already got the denominator. That's perfect. And we will leave it just like that. So that's going to become 20x over 15x squared minus 3 over, oh my god, I don't know why I didn't see that there's not a 1 there. Killing me, Smalls. Sorry, I like imagined that there was a 1 in front of that 5 when I looked at it. That's real bad. This needs to get a 3 over 3. I'm not sure why I saw 15. I think it's wishful thinking. 5x squared. There we go. So now we'll have 20x over 15x minus 9, 15x squared minus 9 over 15x squared. We'll combine those and that becomes 20x minus 9 over 15x squared, and we're done. We could take this one step further, but I prefer to leave it like this. All right, so now we got down to the nitty-gritty. We have some real kind of more hefty polynomials in there to work with. Guys, the rule, the trick is to factor first. Always, always, always see if you can factor first. I could make my common denominator 2x squared plus 2x times x squared minus 3x minus 4, right? I could make it this times this. It wouldn't be wrong, but I'm telling you, you would have so much extra work to do. We're going to save ourselves a lot of time and energy if we rewrite this and factor these denominators. Right, so I can factor 2x squared plus 2x and call that 2x times x plus 1. And then I can also factor that trinomial down there on the bottom. That is going to be, what's that, negative 4 and positive 1, right? Nice. I love that these two are the same because it makes my common denominator a little more simple. And it means that some stuff is probably going to cancel in the end. So then my common denominator for this is going to be 2x times x minus 4 times x plus 1. Which is going to turn out to be much nicer than if we were to try to multiply those two denominators instead. All right. So this particular denominator right here is missing just the x minus 4, right? So that means that I am just going to multiply by x minus 4 over x minus 4. This one here, right, is only missing the 2x. So that means that I'm just going to be multiplying by 2x over 2x. And the thing is just so much easier that way. Rewrite that denominator, and there we go. So now we'll go ahead and multiply. I am going to distribute when I multiply this time. So 3 times x is 3x. And then, right, so I do that times that, and I'm going to distribute that 3 to my negative 4, which is going to give me negative 12. All over. I am actually going to run out of room over here. So I'm going to write it down below. I'll erase that other stuff over there. I didn't anticipate the space issue that I would wind up with. And it's okay that I have space problems because that makes me like NASA. I know, it's okay. 2x times 5 is 10x. I have 2x times x minus 4 times x plus 1. Okay, so now we've got a common denominator. I'll go ahead and put them all over that common denominator. So that gives me, is it fair for me to add these? 13x minus 12, right? I'm going to be combining like terms there. X minus 4 times x plus 1 in my denominator. There we are. Now, when it's asking me for something in most simplified form, I kind of like to do all the mathematical operations that I can, right? So, and if it says perform the indicated operation, this says multiply, right? So I'm going to go ahead and multiply that. Just real quick, let's be tricky about it. X minus 4 times x minus x plus 1. We factored that already, right? So that was x squared minus 3x minus 4. This right here, this piece is x squared minus 3x minus 4. So then I can write this. And now we'll take one more step and we'll go ahead and distribute the 2x. So 2x cubed minus 6x squared minus 8x. There you go. This right here though is an acceptable answer. And on some tests, they'll want you to be able to see it in both of these ways, right? So it's possible that you would get a test that would say, hey, mark all that are correct, right? Or select all that are correct. And this could be possibly an answer, and this one would be an answer, and you would mark them both, right? Okay. Let's move along. Alright, let's perform the indicated operations for each problem below. Well, first we shall factor, right? What happens? Well, that's simplified. It's okay. Can't be factored, but over here, what is this one? I can factor out a 4x. So, that's going to be... No, I can't. How about just 4? Look at me. Too big for my britches. So what's that mean? Well, common denominators. 4 times. Let's write it down. It's 4 times x minus 2. Okay, so that means what I need to do to get a 4 times x minus 2 over here is to multiply both my numerator and my denominator by 4. So that'll be 4 over 4 times 5 over x minus 2 plus 3x over 4 times x minus 2. So that becomes 20 over 4 times x minus 2 plus 3 over 4 times, wait for it, x minus 2. So I wind up with 3x plus 20 over, I'm going to go ahead and multiply this back out. 4 times, 4 minus 8. Oh, we finished it. All right. Oh. We've got another one. And n minus 3 and 3 minus m are the same, right? No. No!
No, Sensei.
My name's Scotty. Alright, so what's my common denominator then? It's going to be m minus 3 times 3 minus m. So what's that mean? That means that this one over here has got to be multiplied by 3 minus m over 3 minus m. I've got to multiply that times 7m divided by m minus 3. And then this one's going to have to be multiplied by the other thing in my common denominator. m minus 3 over m minus 3 times 5m over 3 minus m. I'm going to scroll up now. Because you can't see it in the video, but I'm quite tall. So I need to reach up high. Alright, so I'm going to go ahead and distribute. So that's going to give me, right, so I'm going to multiply that one times that one, which is 21. 21m minus 7m squared over 3 minus m times m minus 3 plus 5m squared, because I'm going to multiply this one times this one. I'm going to distribute as if I was UPS trucks. Negative 15m 3 minus m times m minus 3 in my denominator. And now we could put it all together, we could. Go ahead and combine like terms at the same time. Because I'm running out of room over here. Okay. So 7m squared minus, or negative 7m squared plus 5m squared is going to be negative 2m squared. I'll add these two, the 21m and the negative 15m, and I'll get 6m. All divided by 3 minus m times m minus 3. Now, look at my numerator. Look at it. Look at him. It's about to cry. No, it's not true, but it's factorable. I could factor out a negative 2m, couldn't I? I'm going to do it. 2, negative 2m. That's going to be, well, I wind up with a negative m here, right? Negative m. No. Minus 3 over 3 minus m times m minus 3. So look at this. When you get to the end, you better check and see if things are factorable. Because look at this. Look at, I've got an m minus 3 over an m minus 3, right? And that's 1. It's 1. Like behind them there. So you could cross them out if you like. All of it. Whoa, I've got left. I've got negative 2m over 3 minus m, and that's my final answer, Regis. Okay, number 7 then. All right, Scotty, I'm kicking you out. Time to be serious for a minute. Hey, but really, actually, this one factor is really weird. So let's look at this. It turns out that I can factor this denominator. It is actually a perfect square trinomial. Okay. It turns out to be b minus c times b minus c. Perfect square trinomial. I know it's weird because there are virtually no numbers in there, but I think that I showed you guys enough of these that you should be happy with that. BC Dubs, this is a lesson only for you guys, pre-AP Algebra 2. Regular Algebra 2 doesn't get this one. It's special. It's a plus standard. Thank you. But hey, what's really nice about factoring that is that, look, I've got a b minus c right there. Oh, I got another b minus c right there. Yeah. Double up. Thank you. So my common denominator is b minus c times, that's it. b minus c times b minus c. There we go, right? So I don't have to do anything to my first term, but my second term I do. So my first term is all good, just like this. But my second term needs to be multiplied by b minus c over b minus c over b minus c. A lot of b's and c's everywhere. It's like fucking crazy. Okay. So let's go ahead and multiply this out. So I'll have b squared. I'm going to put it all over a common denominator as well. Our common denominator in this case. The common denominator. So I'm going to distribute b squared times b is going to be, it's just b. Thank you so much. That makes things much nicer. I was about to freak out about the b cubed. I wasn't too happy about it. Alright. And then this winds up being negative bc. Well, that's rather interesting. Okay.
Oh my god.
It's okay, so I wind up with 2b squared minus bc all over b minus c times b minus c. Looks like that numerator is factorable. I can factor a b out and see what happens. I'm not sure if it's going to be helpful. Yes. Just the c is negative. So it's b times positive b, which is positive b squared, and then positive b times negative c, which is negative bc. Yeah? All right, so I erased some stuff. We've got to be careful that this negative sign, right, is this negative sign right here. So just about made the same mistake that I told you not to make at the very beginning of the lesson. And what's going to happen is it's going to change this to a positive when it was a negative before. And same with the other one. So I went with b squared minus b squared plus bc. Because I'm distributing this negative sign. So I'm distributing the negative 1. So hopefully you do your notes in pencil. And that's going to give me just BC over B squared minus 2BC plus C squared. Mr. Dorman, I'd like to do the next one. Okay, you can do it, Scotty. Go for it. Right, yes! So, I'm going to go ahead, since there's a bunch of work over here, I'm going to just make it so that one don't get confused. Don't get confused. I'm going to do some factoring because I love factoring. I love it. I like it. I want to ride my bike. I don't know the expression. So I think that's difference of squares right there. And then this one is going to factor as well. X, I put an X there, and then I put -1, oh my goodness, it's a 2, and a 1, and a plus, and a minus, and I finished. Good, I did it. So my common denominator is going to be x plus 1 times x plus 2 times x minus 1. It'll all work out in the end there. Cool. So in order to get that, I'm going to have to multiply this one times just x plus 2. So x plus 2 over x plus 2 times x over x minus 1 times x plus 1. Alright, and I'm going to write it over here. Our common denominator is x minus 1 times x plus 1 times x plus 2. But thankfully, I think a lot of things are going to cancel out. I've got to bring this up because I'm much taller than Mr. Dorman. He's short. Looks like a wheel. Yeah, that's messed up, dude. I'm doing my math. So I've got to multiply this one times x plus 1 over x plus 1 to x over x plus 2 over x minus 1. I'm going to have to bring this all down here below the Eureka Math trademark symbol. So this, I'm going to distribute. It's going to give me x times, well, let's just write it as I'm going to leave it. I'm not going to distribute it right now. So x plus 2, x minus 1, x plus 1 minus 2x times x plus 1 over x plus 2, x minus 1, x plus 1. There we go. We'll put them all together. I'm going to wind up with x times x plus 2. Remember, this minus sign is going to live with my 2x. Okay. So now I'll go ahead and distribute and combine like terms. So I have x squared plus 2x when I multiply out the first one. And now negative 2x times x is going to be negative 2x squared minus 2x. Take that, math. X minus 1 times x plus 1. Let's combine like terms. Oh, well, I got left over here on the on the numerator. I think I'm catching a wee cold. I get negative x squared over x plus 2 times x minus 1 times x plus 1. And we'll just leave it like that for now. We can multiply it back out, but we're about to run out of time. And I've got to get faster if it takes some. The next one's a doozy. Alright, last one. So they left you a lot of room on this page for a reason, by the way. So the first thing, so this is my plan, okay? I'm going to take my numerator. I'm going to get it to be just one expression. I'm going to get my denominator and get it to be just one expression. And then I'm going to flip and multiply. Okay? Because remember the whole, some people remember it as like copy dot flip or whatever for the for dividing, because we are dividing. It says this says b squared plus b minus 1 over 2b minus 1 divided by, right? 4 minus 8 over b. Yeah, that's what we're doing. So the first thing I'm going to do is I'm going to work this numerator. So that means that, and I'm going to go kind of quick. So it's going to be minus. If I was to multiply that so I could get a common denominator, it actually just turns out to be 2b minus 1 over 2b minus 1. I'm going to work the denominator at the same time. I'm going to have to multiply 4 over 1 times b minus 1, b plus 1 times b plus 1. So that's 4b plus 1 over b plus 1, right? That's the same thing as 4. Minus 8 over b plus 1. There we go. Yeah, we just went to the next level. So now I'm going to take my numerator here. Remember that this minus sign is going to actually distribute everything over here on my other numerator. I'm putting them all over the same denominator. I'm going to do the same thing with my other numerator, right? I like to make this one a little bit longer so that I know what's what. So this is going to be 4b. I'm going to distribute 4b plus 4 minus 8 over b plus 1. Pretty nasty, but it's good. We're going to get through this. We'll do it together. I won't let go, Jack. Psych, you're going to die. There was enough room on that door for them to both be there. But she's afraid. She's not literally afraid. Okay. Sorry for the vague Titanic references.
The rest all the time, but
You say 0 words now. I'm just combining like terms now. Okay, time to combine like terms on this first numerator. So that will give me b squared minus b. That's it, right? Over 2b minus 1 over 4b minus 2 over b plus 1. It already looks better. Everything's getting much better already. Now it's time to flip and multiply. So I'll wind up with b squared minus b over 2b minus 1 times, right? And I'm flipping this denominator. I'm taking all this stuff and I'm flipping it. All right, I would like to see, is it possible for me to cancel anything? Let's factor real quick, okay? So over here, I'm going to factor these. I'm going to factor a b out of this one. That's going to give me b minus 1, 2b minus 1, and then this one I'm going to factor a b plus 1. And over here, I can factor a 2 out, and that's going to be 2b minus 1. Yes. So guys, these are going to cancel, right? So I wind up with b squared plus b over 4b minus 2. And I think that's as far as we can go, right?